Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Vorhies, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. So I'd like to start off our event today by thanking Looker for sponsoring today's event. Looker is a valued supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, past webinars are available on demand at datasciencecentral.com. And if you haven't had the opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. Now, today's webinar is entitled Modern Data Science Workflows, and that'll be presented by Looker. And before we begin, I'd like to briefly review the format for today's webinar. Today's event will be an hour long. We have three presenters who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation, and this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation, as we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speakers, Haarthi Sadasivam and Olivia Winter, both with Looker, and Julian Winternheimer with Buffer. Now, Haarthi is a product manager at Looker. She spent the last 3 years working with Looker customers, helping them build actionable data pipelines. And prior to Looker, Haarthi was at Citi with their bonds trading desk platform team. She's a graduate of the University of Virginia. Now, Olivia is a customer advocate at Looker. She spent 8 years in neuroscience research and analytics at Oberlin College and Stanford School of Medicine. She then took her data skills into business operations for 2 science and tech startups. And in her 2 years at Looker, she's been educating and guiding businesses through setting up and managing their data stacks from ETL through APIs. Julian is a data scientist at Buffer, where he builds statistical models and tools that help his teams make better decisions. He has his degree in statistics and economics from the University of Wisconsin at Madison. So Haarthi, Olivia, Julian, hey, thanks for being with us today. We're looking forward to your presentation. Now, in today's presentation, we'll explore how innovative companies are modernizing their tech stack and workflows to allow data scientists to spend more time doing advanced and predictive analytics, the highest value parts of their job. So join us today for today's Data Science Central webinar and learn how data scientists across different organizations have influenced and changed analysis behavior across their companies. You'll also learn helpful tips for integrating data science findings into your organization's decision-making process. So Haarthi, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Awesome. Thank you, Bill. So before we get started today, I think we're actually going to start with 2 poll questions just to get a sense of the audience. So our first poll question is just going to be around how familiar you are with Looker. Have you heard of Looker? Are you somewhat familiar, not familiar, or very familiar? So I'll give everyone a few seconds to kind of get their responses in. And I can also talk a little bit about Looker while everyone's getting their responses in. Looker is a data analytics platform that connects to any SQL-compliant database. And what's special about Looker is that it provides a reusable modeling layer that helps maintain business logic throughout the organization. And once you do have that business logic, Looker helps operationalize that logic in the form of shareable content, which could mean reports, dashboards, emails, actions, just to name a few things. Awesome. So it looks like a large majority of the audience here hasn't heard of Looker, and that's fine. So we'll definitely kind of touch on Looker, but kind of focus more on data science workflows. The next poll question is kind of what is your current biggest challenge in your data stack and your data flow? Is it the data preparation and data cleansing? Is it the actual analysis? Or is it kind of operationalizing that analysis in the form of being able to share insights? Or is it something completely different? And again, I'll give everyone a few seconds to answer that. Awesome. So it looks like, data preparation and cleaning is kind of the biggest struggle, and we'll actually touch on that quite a bit during this webinar. So today we're going to be talking about how data science can be used for business optimization, all the way from kind of being able to optimize time through the research process to identify and take action on opportunities, to being able to find ways to grow within the company. So data scientists usually ask questions like, how can I optimize my ad spend or my ad strategy based on some sort of user behavior? Or how can I, fine-tune my site to serve more relevant content? So today we're going to be really talking about how to take those pieces of analysis and help influence decisions, kind of just backed by quantitative analysis. So the typical data science workflow looks something like this. We find that data scientists typically spend a considerable amount of time preparing data, which includes merging, reshaping, and cleaning this data in some sort of data science environment. And then once the data has been prepped, they finally feed it into some sort of specialized tool with machine learning capabilities or advanced statistical capabilities to run all sorts of data science models like regression, clustering, deep learning techniques. But a lot of these advanced analytics workflows are very iterative. So, you'll need to constantly update your model to include additional variables. And in this case, with this type of workflow, that means you're repeating steps 1 and 2, the extraction and data prep phase, multiple times in order to arrive at an optimal data set. And then once you've finally applied your data to your model and you have something to share, you're faced with kind of the question of how to get these findings out of this environment and out to your stakeholders for review. And because visualizing data and then sharing it isn't really the core function of these data science environments, it's often a very labor-intensive process. So, within this data science environment, an analyst may need to go in and learn how to leverage brand new visualization packages, and they might spend a lot of time building out new visualizations and figuring out the most appealing way to show the results of this analysis. And then the operationalizing piece of it also is a challenge. You'll have to figure out how to schedule cron jobs and figure out a way to distribute information across the organization in a way that isn't stale. For example, just emailing out a visualization or a report that quickly becomes stale, it doesn't necessarily inspire action from your findings and your analysis. So with this type of workflow, a data scientist really spends a bulk of their time in their data science environment kind of doing the prep and clean work, and really only a small portion of their time is spent doing the things that the data science environment is best at, which is advanced analytics. What are some ways that we can kind of add to this workflow to reduce the time that data scientists are spending on that modeling and prepping phase of this workflow? So, we talked about the typical workflow, but, with other types of workflows, data scientists can leverage work created by the data and analyst orgs within an organization. So any data-driven organization, if they use a tool like Looker, they're usually already stitching together multiple data sources like Salesforce, GA, Zendesk, and they're defining kind of common shared definitions for their metrics. So, they have a definition of monthly active user or customer lifetime value, and these definitions kind of mean the same thing to everyone within their organization. And so if you do have that in place as a data scientist, you can leverage this curated data and then pull it into the tools that you use for advanced analytics like RStudio, Jupyter Notebooks, TensorFlow, and and many others. And once you then have the results or a model, the data scientist can leverage the rest of the org, the data analysts and the BI experts to visualize these outputs. And then you can combine that with the rest of the workflow and show it in the tools that the rest of the organization is already using. And with this type of workflow, the data scientist is spending a bulk of their time in step 2 and not really in the data cleansing extraction process or the operationalizing process. So let's look at this modern workflow in action. In the example that I'm about to show, we've pulled together data from the Seattle bike share program into Looker. And Looker, again, has that data governance layer, so we're able to define certain types of relationships between metrics and see those relationships between the different data points. So, based on some of the things that I'm pulling in here, it looks like there is a strong correlation between the temperature on any given day and the number of trips taken from the Seattle bike share program. So let's pull this data into Jupyter Notebooks via the Looker API, and let's apply a model on it. If we decide that we need to pull in different dimensions, so we've pulled in temperature and we've pulled in trip counts. So say we want to see how humidity affects the trip count, we can easily go back into Looker and just click on that particular field and send that data directly into Jupyter Notebooks and update the model. Say we, again, want to maybe look at the impact of temperature and humidity or any number of other factors, it would just mean going back in and clicking on those fields that we want that have already been defined for us and sending those to our data science environment to run that model. And so once the model has, some sort of output, some sort of coefficients, we can pull that back into Looker to visualize, in this particular example, what trip counts could look like for the upcoming week. So we're able to look at weather forecasts, and we're able to pull in the coefficients from our model, and we're able to forecast these trip counts for the upcoming week. And taking this a step further, we can even segment this by bike stations in Seattle and predict which stations will tend to have kind of an overflow of bikes for the upcoming weeks based on the forecasted weather for that upcoming week. And to kind of take action on this, we can schedule this dashboard to be sent out to all of our station monitors in Seattle to kind of help them rearrange the overflowing bikes and kind of take action on this piece of analysis or this insight that we've found. So in that particular example that we just walked through, the most crucial step is really just creating that operational dashboard that allowed the key stakeholders, and in this case, the station monitors, to take action on the findings from that model. So with every kind of analysis that you do, with every data science finding, just make sure to communicate the results of your findings and present those findings to the rest of the org. And this can be done in a number of different ways. It could be something, as simple as creating a reporter dashboard, as we just saw in that example, that visualizes your findings. It could also mean doing something more advanced, like creating a data science product or web page that allows your end users to interact with and kind of allows end users to enter in input to adapt your model. And this allows users to, get answers to their own what-if scenarios and really allows them to be inspired to take action on kind of the things that they've found. And don't forget to kind of reflect on and implement your findings. So with every data science workflow, what are some of the changes that need to be made based on the findings? Was this project worthwhile, and what was kind of the return on investment on this work? So kind of with every insight, go back, ask those questions, and really quantify the findings and see if there is anything actionable that you can take out of it. And so with that, I am happy to pass on to Julian from Buffer.
All right, thank you, Haarthi, and hello, everyone. Thanks so much for spending some of your day here with us. I'm very happy to be here and to share a little bit about how data science works at Buffer. As Bill mentioned, my name is Julian, and I'm a data scientist at Buffer. I've been here for 3 years, and I'm based in New York City. So I have about 15 minutes with you all, so this is what we're going to cover. I'll start by sharing a bit about Buffer, what it is, and how the team is structured. Then we'll go over how the data team operates within the company. I'll share a bit about our data infrastructure and the tools that we use. And then I'll give an overview of our data science workflow, our analytic process, and we'll walk through an example of a data tool that we built. Does that sound good? All right, let's do it. So Buffer has a suite of social media tools to schedule, analyze, and engage on social media platforms. Our published product saves individuals and companies a lot of time by letting them schedule their posts out in advance. We also have a product called Reply that helps teams engage and interact with people across the networks in a smooth way. It's sort of like a Slack-like tool for Twitter, Facebook, and Instagram DMs and mentions, and it's really useful for support teams. We also have a new product called Analyze that provides some deeper insights into social media data. As of today, we're a team of 71 and we're fully remote and distributed. It means that we don't have an office and we're located around the world. We do get together once a year for a team retreat, and the data team also tries to get together for mini retreats. The last team retreat we had was actually a few weeks ago in Singapore. Buffer is also fairly well known for its transparency. All of our financial data is online, as well as our salaries. We try to publish a lot of our internal analysis and processes on public repos, and we also try to contribute to the open source community as much as we can. I'll share much more on this later. I only mention these things because they have a huge influence on the way we think about data. People are spread across time zones, and English isn't everyone's first language. So we need to communicate very deliberately, and the data that we have needs to be quite actionable. It's difficult for us to tap someone on the shoulder and ask for help, and it isn't unusual for email discussions to go on for weeks. We're just not set up the best for synchronous real-time communication. All right, so now I'll give you an overview of the data team. We are quite small. There are only 4 of us with 2 data scientists, 1 data engineer, and a data architect. And we handle everything from infrastructure to business intelligence and deep analysis. We are a centralized team, but we're also cross-functional. I work primarily with the product and finance teams, but I also help out with data analysis across the company. Because of the small size of our team and the makeup of our company, we put a lot of effort into making data more accessible, and Looker does play a big role in that. Throughout this webinar, I'm going to focus more on the technical details with you all, but I want to emphasize again how important it is for us to communicate the results of our analysis clearly and make data actionable for the rest of the team. This really drives a lot of what we do. All right, so now let's talk about how we think about data at Buffer. The slide that you see now contains the current vision statement of our team. We want to make data a driver of innovation, growth, and quality. Our goal is to deliver insights that lead to better decision-making, and we want to create a better experience for Buffer users, and we want to make Buffer a more successful business overall. It isn't included in the slide, but we also have a heavy focus on education. We occasionally host snack chats, which are just short presentations, usually given during a lunch hour, in which we explain interesting concepts or technologies. The most recent one we did was on our data architecture, which I'm going to go over shortly. We've also recorded lots of little screencasts to help people analyze data on their own. They can be on anything from downloading a CSV from Looker to estimating sample sizes required for A/B tests. We just have to do this kind of stuff with such a small team and the resources that we have. It's also just kind of fun to do. So the goal of all of this education, of course, is to enable the rest of the team, especially our product managers, to analyze their own data and free up the data team to be less reactive and spend more time on deep analysis. All right, so that's our vision. Now I'm going to talk about strategy, or how we actually get the work done. Every few months, we make high-level bets using the DIB model that we borrowed from Spotify. DIB is just an acronym for data, insights, belief, and bet. The idea is that you take some observation from your data, derive some insight from it, form a belief or hypothesis, and then make a bet. Bets should include an expected payoff and will always include some inherent risk. Bets should move us closer to achieving our vision and guide us when we write pitches for our individual work projects. We work in 6-week work cycles, and every cycle we revisit the bets that we made and assess whether they're on track and if we're getting the expected payouts. So I'll share just one example of a short bet that we made this cycle. We noticed that we spent a lot of time interpreting visitor experiments with the marketing team without a clear understanding of the experimental design process or what the ROI of that marketing effort was. Our bet was that by building an end-to-end experimentation system for visitor experiments, we would make the marketing team more efficient and would, in the end, lead to more quality leads at Buffer. So once we have our bets, we write pitches that are more detailed and scoped out and decide whether to include them in our 6-week work cycle. They should each fall under the theme of one of our bets and contribute to our vision. All right, so now I'm going to shift gears a bit and tell you about the tools that we use. I've asked our data engineer to provide the description of our technical stack just because he does a much better job at explaining it than I do. So here it is. Our data pipelines are made up of several components. Each component takes care of one specific thing and communicates with the other components using event logs. For all of these pipelines, we always need to have some sort of producer. For example, if we want to add Stripe events to our database, we'll need to have a producer. And in this case, a simple Stripe API crawler will do the trick. Producers read events from the sources and forward them to the event log. In our case, we're using AWS Kinesis streams. Producers will call the Kinesis API and place data into the stream where it lives for 24 hours. Once the data is in the stream, consumers can then read it. We call all components that read from streams consumers, and they are the key piece of each pipeline. They'll read the raw data and apply some sort of transformation to it. Some pipelines will require more complex transformations, and if that is the case, then we can chain together multiple consumers and place Kinesis streams between them. Finally, once the data has been transformed, it's placed into S3 and copied over to our data warehouse, which is Redshift. And then from there, it can be extracted to Looker, R, Python notebooks, or whatever you want to use. I'll quickly touch on the key technologies that we use in this architecture. We use Python. We use protobuf as the preferred data serialization format. We use gRPC. Kinesis is our choice of distributed streaming platform, and we place all of our events in the Kinesis stream. AWS Lambda is our serverless computation layer. Kinesis events trigger our Lambda functions. We use Firehose to facilitate data flows between Lambda, S3, and Redshift, and we store all of our logs in S3. Redshift is our data warehouse. We use dbt for scheduled jobs, and we use Datadog for monitoring. The data scientists primarily use a combination of dbt for batch jobs. We use Looker, R, and Python for exploration and analysis. And we use R or Jupyter notebooks along with GitHub for presentation. Okay, so now I'll describe our current data science workflow at Buffer. I should mention that we're continuously developing and evolving our way of thinking about this, so these methods may change over time. We do try to document our workflows and processes out in the open, and you can find many of them in the Buffer app organization in GitHub. So I'll start by describing the most common types of problems that we work on, and then we'll go through our analytic process, and I'll share a bit about the tools and methods we use at each step. Finally, we'll walk through an example of a high-impact data project that we've worked on. Okay, so these are the most typical types of problems that we work on: building data pipelines, defining metrics, creating reports and dashboards, building internal data tools, delivering product insights, and facilitating experiments. Before we get into it, I'll quickly share a screenshot of a data tool that we've built for the marketing team, just to give you a little example of what I'm referring to when I say data tool. I'll talk in depth about another one in just a few minutes. This is just a tool that we can use to estimate the sample size required for an experiment. As you probably know, it's useful to have a sample size requirement so that you can estimate the amount of time that experiment needs to run. All this is a Shiny app that I built in R, and it uses the ggplot2 and Power packages. And a fun fact, most of this code was actually copied from a similar tool that Julian wrote for the Stack Overflow team. You can view the tool and the code at julian.shinyapps.io/power_calculator. Okay, so now I'll list the steps of our analytic process. They're pretty standard. The first step is defining the scope of the question and the requirements. Then we retrieve and tidy the data, do some exploratory analysis, some modeling and inference if necessary, and then finally the written analysis and presentation. Let's start with defining the question. It usually goes something like this. A PM or a team member might have a question about something they saw in a report or in an analysis. We'll work together to define the question in terms that can be answered with data. We have an internal repo that we call data requests that we use to keep track of these questions, and you should see an example of one now. Whenever a question comes in, we'll just create a GitHub issue. In this example, Super, our PM for the published product, just wanted to know the distribution of the number of Twitter profiles selected in a composer session. He was only asking because of a recent policy change that Twitter made to fight spam and restrict automation on their platform. We were no longer going to allow people to schedule tweets in multiple profiles in a single composer window, and Super was curious about the impact of that change on our users. This GitHub issue was continuously updated throughout the analytic process and was eventually closed when the question was answered sufficiently. Okay, so let's talk about data extraction. As I mentioned earlier, we use Redshift as our data warehouse, and we use Postgres to extract that data to our local machines. Most of our data is modeled nicely in Looker already, so we can also use that to get a sense of what the data looks like and how the different data sets are related. Like you all, I spend a lot of time on data collection and feature engineering. Our data just comes from a lot of sources. We have an internal tracking tool. We use Google Analytics, Stripe, MailChimp, Wootrick, a whole bunch of things. We actively try to minimize the time it takes to extract the data we need from these various sources. If the question I want to answer is very specific, I'll usually just write the SQL query in a code chunk in an R notebook. However, in many cases, I'll also use Looker, especially when dealing with pre-aggregated data and data coming from many different sources. All I'm doing there is avoiding rewriting complex SQL queries. We've already written these in several of our Looker views, so we can leverage the work that we've already done there. What we do is we retrieve the data from these saved looks and tables via the API. It's so much easier and quicker to do this than to write out all of the SQL every time. We access these tables and views with a simple HTTP request that we wrap in a function in the buffr package that we've developed internally. I'll show you an example of this in just a minute. We do try to abstract away many of these common operations in our packages and libraries. Now, I will say if you happen to use Looker, you should check out their lookr package. We decided to write our own functions because we didn't need all of the functionality that the lookr package provides, and we didn't want to rely on Java. However, it could be super useful for you. All right, so when I do grab data from Looker, I use a getLook function that's part of the buffr package. And I'll usually grab data from a single view that we've created that contains all user-related data. It contains actions, subscriptions, payments, profiles, updates, you name it. Any user-related attribute is in there, and we call it the God view. For analysts, it's super handy to have access to all of this pre-aggregated data. An added benefit is that when the analysis is published, I can just link to the look I use and anyone can access it. Another key benefit is that when we use the exact same numbers the rest of the team uses in their reports, it just fits together well. If they build a report in Looker, we can see exactly how they transform the data and replicate that in our analysis. Okay, so next I'm going to talk a bit about how we do exploratory analysis and modeling in R. For almost all of these tasks, including data tidying, I'll use the tidyverse. Tidyverse is a collection of R packages that share common philosophies and are designed to work well together. It uses pipes to allow the output of a previous command to be used as the input to another command, which is a great intuitive alternative to nested functions. It's just super easy to follow a series of operations in the code. For data tidying and munging, I'll use the dplyr and the tidyr packages. These two packages have totally changed my life and have saved me countless hours of tedious work. If you're an R user and you haven't already read up on these packages, I highly suggest that you do so. ggplot2 is my go-to package for creating exploratory plots, and the Plotly package is also great for interactive graphics. When combined with Shiny, an open source package that lets you quickly spin up web apps, ggplot2 and Plotly can be extremely effective in communicating your analysis. With Shiny and Plotly, team members can control the inputs to an analysis and see how the outputs change, which is very, very powerful. The techniques we use for modeling vary pretty widely and depend on the types of questions we want to answer. We generally only do advanced modeling occasionally, though. For the most part, we're doing basic arithmetic, power tests, and visualizing distributions. We provide the narrative and context for a given data set because we've been on the team for a while and we just understand the business logic well. We've also wrestled so much with the data throughout the entire pipeline. We do use different tools for modeling, and we don't have any strict rules there. I primarily use R, but we also use Python, and very occasionally we'll also use TensorFlow and Keras for neural nets. Now we'll move on to the presentation of analysis, which is one of the most important pieces. I prefer to use R notebooks, which are just markdown documents with code and plots combined in single reports. And these analyses are meant to be totally reproducible and can be reviewed by any member of the data team. When the analysis has been reviewed and is ready to be published, the code is merged into our analysis repo and is published as a GitHub page. It's sort of like an internal data blog for us, and it makes it easy for anyone in the company to find analyses. It's also useful to learn from each other on the data team. This slide just contains one example, but if you look at my Twitter profile, which I'll share later, I've shared many links to other internal analyses that you can find on GitHub. As I mentioned earlier, it's very important for us to make our data as actionable as possible. We often write results back to Redshift so that we can use them in reports that we build. Here's an example of how we do this in R and in Python. When we do this, we'll often model this data in a Looker dashboard and create a scheduled email that goes out to the stakeholders. And I'll share one example of this in action now. So the last thing I'll share with you today is an example of a high-impact data tool that we've built to help the exec team make more informed decisions. It's an application that we have running in production today, and it's basically a simple revenue forecaster that retrieves monthly recurring revenue data, forecasts it in R, and writes it back to Redshift. The project is open source, and you can view all of the code in the MRR/forecaster repo in the Buffer app organization in GitHub. I'll share some context around how this project came to be. As a subscription-based SaaS business, we get plenty of questions about MRR. We've been pretty heavily focused on growth in the past, so it was very important for stakeholders to have a solid understanding of our revenue projections. Whenever we got those questions, we'd have to run this heavy SQL query to compute MRR for a given time period. And we also had a scheduled job that ran this query every night to calculate the previous day's MRR value. Eventually, we built a small, simple service to forecast MRR out in a month. And here's how it works. Revenue data is pulled in from a saved view in Looker with the getLook function that I mentioned earlier. The revenue data is then aggregated by day, and the time series object is created from it. An exponential smoothing state space model is then fitted to that data. And the forecast itself is created from the model with Rob Heineman's forecast package. The modeling is made simpler by the fact that our revenue growth has been so linear, as you can see now. Finally, the application writes the model results to Redshift with the write to Redshift function that you saw earlier. We've added this application to Docker, and it runs as a cron job in our Kubernetes cluster. The Looker dashboard that we use for our MRR report includes a tile for revenue forecasts and pulls data from this table. This number is shared with the executive team every day and is very useful for our high-level strategy. My favorite thing about this tool is its simplicity. It's less than 100 lines of R code, and it saved untold hours projecting revenue. Our revenue growth has been very linear, and it doesn't require complex modeling. But I'd like to highlight the fact that simple approaches, particularly linear models, can work well for many of the problems that we face. All right, everyone, that's all I have for you today. If you have any questions that I don't get to in the Q&A, please email me at julian@buffer.com or tweet at me. Thank you so much. I think now I'll pass it on to Olivia.
Thanks, Julian. That was so great to go through your workflow. Today, I'm going to be presenting a little bit about Dr. Julia Filge, or Dr. Julia, she likes to go by, from Stack Overflow, and how she uses Looker to increase the value of Stack Overflow's data. So if you're on this webinar, chances are you are one of Stack Overflow's 50 million daily visitors. As you know, Stack Overflow is the largest and most trusted community for developers to learn, to share, to ask questions, to answer questions. It's just such a great resource across many different coding platforms, and for any noob out there, just a fantastic way to learn, for experts, and a fantastic way to also contribute. What this results in is about 9 terabytes of data that the data scientists are working with at any given time. And that just comes from the event information of each visit that a customer is paying to the website and every question asked and answered. What you may not realize is that Stack Overflow is actually a two-way marketplace. So, of course, most of us are familiar with their fantastic community for developers, but it's also a way for folks to find engineering talent. And for the data science team at Stack Overflow, what this means is asking 2 sets of questions. One is, how do we optimize the user experience for our engineers and coders who are coming to the website to ask and answer questions? But also, how do we make sure that we're delivering the right information to those looking for talent and of course, retain those paying customers to continue to support Stack Overflow's mission. Now, before Stack Overflow adopted Looker, they had what will probably be a very familiar situation for a lot of us. When folks are just working with single event data in a single table, things are relatively easy. Julian mentioned, if it's a simple query, I'll just write a one-off SQL query directly and pull that data from that particular production or analytics database. However, when you start to get into the questions around how to optimize business, as Haarthi mentioned in the very beginning, and as a lot of you clearly have questions about, it comes back to cleaning data. Some people call this cleansing, some people call it munging, some people call it the worst part of being a data scientist. And ultimately, for Stack Overflow, what this meant was integrating many different kinds of data. They had traffic data, event data, demographic information, survey data, and then, of course, the dreaded sales process data. So they were pulling information from the sales team, CRM, finance, from marketing, and ultimately what was happening for the data science team was that they were just spending hours and hours of their time interviewing different folks within the company about how they were computing metrics. How do we count a repeat visitor? What does retention mean? What is our customer acquisition cost? And so in order to do any deeper analysis on really interesting data science questions, in the example that Julia talked about, or Dr. Julia talked about, was the question of how much time should our customer success team spend with our talent customers to make sure that they renew? But before she could even get to that question, it was all this data munging, data cleansing, talking to individual stakeholders within Stack Overflow to ensure that they're even defining metrics the same way. What this meant was an incredible lack of reproducibility. And of course, just not the most fun for the data scientists. Now, some of you are, seeing Looker and thinking, this is a business intelligence tool. We don't do BI. We are data scientists, not analysts. And that was the thought process, frankly, that Stack Overflow data scientists had at first. They saw it as a BI tool and they weren't that interested. But the fact is that because the output of a Looker query can be piped into any Jupyter Notebook, RStudio, or any of the data scientists already familiar stack, Looker became this incredibly flexible way to create a single source of truth and to avoid all of the data cleansing. So to kind of walk through this a little bit of a busy diagram, what's happening is that extract and load and database ownership, you as data scientists might do part of this, or you might have a DBA or Eng team that manages it. But what the end result is that Looker sits on top of that database, and the entire business team, all of the metrics across your organization, including the metrics that you typically define in sort of pre-transformed or aggregated data sets that you might be using, those now all happen in Looker. That big purple box in the middle, that represents our modeling layer, and this is where the time savings and the reproducibility come in. So for the Stack Overflow team in this example, they pulled in the underlying metrics from across business stakeholders about customer acquisition costs, retention rates, how are sales defined, which data sets are the most important, and they then streamlined the process of pulling that data into their existing data stack. Again, once they realized that they could use Looker as that data transformation and SQL query writer and just pull the results via API into whatever tools they already wanted to use, that was the winning combo for Stack Overflow. The result for Stack Overflow team was that what used to be many hours of work literally became minutes. And for the particular example that we were briefly discussing today, it resulted in a nearly doubling of the renewal rate in the first year of their new customers' life cycle. So pulling that data from Looker really meant reducing the amount of time that the data science team was spending on data cleansing and allowed them to focus on more critical questions that you guys all want to spend your time on rather than, what you might call the worst part of your job, that data cleaning step. Now, I want to quickly go back to this slide really briefly because there were a couple of questions before I even get into the Q&A section about the how. And I do just want to reinforce that with Looker, we connect directly to your database and allow you to query that database through this centralized data model. The data then can be pushed out via API into your existing workflow. And then there was also a question about, well, once that data is out and analyzed, say in R or some other statistical or modeling package, how do I then view it or display it? And I apologize, there's no arrow here, but imagine an arrow back from your package back into the database. So that data result or the results of your analytics or your model are going to go back in the database and allowed then to be pushed out by a visualization into your web interface via end users or embedded or scheduled out to the rest of your company. So that's a quick start to our Q&A section. And I'd like to thank the Buffer team as well as Stack Overflow for being fantastic presenters and explaining how they use data, and turn it over to Bill at this point to moderate our Q&A section of this webinar.
Well, Haarthi, Olivia, Julian, hey, thank you for that excellent presentation. We'll get started with today's Q&A session, and I want to thank the audience for their participation. We've had a lot of questions that have come in, and we'll do our best to get through all of them in the time remaining. So during this Q&A session, I'll leave up this slide with contact information for Haarthi, Olivia, and Julian in case you'd like to contact them following today's webinar. So let's get started. Let's see. You showed us that Looker has a data modeling layer. Can you clarify whether or not you can do data science modeling directly in Looker or just external to it?
Yeah, this is Haarthi. I can take that question. So we kind of talked about Looker's data model, and Looker is a great tool for analytics. Looker makes use of a lot of the common database functions that are available with the databases that we connect to. And so Looker, I think, is very great for simple A/B tests, some regressions, maybe some correlations or affinity analysis. And so Looker can cover about 80% of the types of analysis or analytics that you're trying to do. But for kind of the more sophisticated data scientist, advanced analytics use cases, I think the recommendation is still going to be to take your data from Looker, to take that modeled data into R, Python, or another machine learning tool. So short answer, Looker will cover about 80% of use cases, but for that other 20%, for that advanced analytics portion, we do recommend that you take your data from Looker into some of those tools that are specifically built for that.
Okay, well, thank you very much for that answer. The audience is interested to know about some of the automated machine learning platforms that are available today, like DataRobot and Big Squid and many of the others. Does Looker work well with those as well?
Yeah, I can start again there. So some of these other, automated machine learning tools, you mentioned DataRobot, Big Squid, they are definitely a piece of the puzzle. So I think Looker kind of works really well with them. We have complementary approaches. So while Looker kind of handles the, the data cleansing, extractions, and the modeling process, and while Looker helps automate user workflows, these tools, are the ones that actually handle the advanced analytics portion of that data science workflow. And so Looker works really well with those kinds of tools.
Okay, well, thank you very much. A question about capacity, and I guess this has two parts. First of all, are you actually pulling all of the data into Looker to analyze it, or is it being analyzed in database? And if in Looker, is there any restriction on the number of rows, for example, that I can export to RStudio or a similar platform?
Thanks, Bill. This is Olivia. I can sort of tackle that two-part question. I saw a series of questions about what exactly is Looker, where does the data live, and then how do I access it? So try to give a quick on that one. So Looker is a data analytics platform. It is a software, a SaaS product, and it can be hosted either in the cloud or on-premise. The application itself does not store your data. So your data is going to stay in your database, databases, data warehouse. Yes, it could be Hadoop. It could be anything as long as there is a SQL connector. We work with about 40 different dialects. Now, once that data is in Looker, you will create a data model. That is what is special about Looker. That data model is that way that we streamline the metrics and make sure everyone knows, has transparency around how those calculations are defined. And then out the other side, you can either have folks build reports directly within Looker or push out the data via API. And the good news is there is no limit to the API calls or pushes into your R or other statistical package. So you are unlimited in the amount of data that you can access via Looker. If it's in your database, Looker can access it, which means so can you.
Well, thank you for that clarification. And just to make sure we're clear on this point, one of the audience members asked specifically about Hadoop. If you go back far enough, we think of Hadoop as just NoSQL, and you say Looker can connect to any SQL-compliant database. Hadoop included?
Yeah, a little bit of a confusing point there. So we talk to anything that talks SQL. So if you have Hadoop, but you're using, say, a Spark SQL connector, we can talk to your Hadoop DB, that unstructured data, via that connector. You will need to have some kind of SQL dialect speaking connector or a direct SQL database. Very popular databases would be something like Snowflake, Redshift, BigQuery, et cetera. There's a whole range of them. You could even work with Looker on MySQL or Postgres, or again, those Hadoop databases via a SQL connector.
Well, thank you. Thanks for that clarification. The audience is asking, how is Looker hosted? Is this on-prem? Is it a service? Is it on my laptop? Is it on a server? What are the options that you have for providing this?
Sure, this is Olivia. I will continue to clarify that point, excellent point. So Looker itself is an application, and typically most of our customers prefer to have us host it. We host via AWS. However, the application itself can be hosted by a jar file on a Linux server, so either a private virtual network or your individual on-prem server. The second answer to that question was, how do you access it? So what is very special about Looker? A lot of our good folks who've worked with Tableau or other desktop tools really like about Looker is that you do not download the actual application. Again, it is totally web-based. So with Looker, you will access the application via your web browser, like any web app. However, the software itself can be hosted on web or in on-prem, such as with healthcare, finance, or other sensitive data.
Well, terrific. Hey, thank you so much for that answer. Now, in terms of getting started with Looker, the first thing that people always want to know, well, gee, is there a community or developer edition for Looker? But beyond that, what are the resources for learning to work with Looker?
This is Olivia again. I love that question. It's something that customers ask and folks who are just getting started want to know, I have never seen better documentation than what we have with Looker. So in terms of what is directly available to you, there is a fantastic and well-curated set of documentation that will take you through the entire onboarding process. But of course, we have real people too. So we have professional services who help train and onboard folks. If you're more of a self-service type, which probably a lot of data scientists are, you can use online webinars or direct co-development sessions to learn. And if you are interested in getting started, there's lots of resources on the web to find us or directly email us. And we're happy to also hook you up with a Looker Learn instance. So we have a set of pre-curated metrics and connected to a sample data set. If you just want to poke around and see what it would be like, we can give you a free access to that Learn instance.
Well, terrific. Oh, that makes it very convenient. Oh, thanks for that answer. A technical question, I think you talked about this, but let me make sure that we cover this for this audience member. And that is, when you say that you pull that data back into Looker, referring back to an iterative step early in your presentation, is that automatic, or are you pushing it into Looker by API, or how exactly is that working?
Yeah, that's an important clarification. Oh, sorry, Haarthi, go ahead if you'd like to step in here.
Oh, sure. So I was just going to say, to get data back into Looker, what we're actually talking about from these data science environments is pushing it back into a database that Looker can connect to and read from. So from, our Python, your Jupyter Notebooks environment, you might push your data back into, a database like BigQuery, and then Looker would automatically connect to any sort of SQL compliant database, and you'd be able to view your results and operationalize them in Looker.
Terrific. Okay. Well, thanks for that clarification. And one last question. I understand that you have a new connector for the R SDK and Python connections. Can you tell us a little bit about that?
Yeah, and I can take this question too. So Looker, we have a full-fledged API that allows anyone to connect with Looker and request data and metadata. And so we're in the process of making that Looker API that much easier to access with our R SDK and our Python connections. So what that means is within kind of your data science environment, instead of issuing, SQL queries directly to your database and kind of manipulating those queries and creating data definitions, you can just issue calls through Looker's API either via the R SDK or through Python connections and get data just straight into your data science environment. So all your queries just come through Looker's data model, and it's already tidied up, and it's just a simple call from your data science environment.
Well, thanks. Thanks for that clarification. And actually, we've had one last question come in from the audience that looks like it could be important, and that is, would you tell us a little bit more about the extent of data cleaning capabilities in Looker? Is that automated? Is it schedulable? What can you do in there for the cleaning and prep steps?
Yeah, Bill, this is Olivia. I'll take that question. So folks really love the ability to not have to pre-transform their data before using Looker. So we like to say with Looker, you're going to go through an ELT process rather than ETL. That is, you E and L, extract and load your data into your database. And then the transformations, the majority of your transformations, I should say, are done on the fly via the SQL that Looker is automatically writing. And the way that SQL is generated is based on the model that you've created. So the cleaning, what we mean by cleaning, is that transformations that you want to make, whether it is removing bad values, making sure they're only computing non-null values, dividing, multiplying, that are applying any basic arithmetic or statistical computation over that existing table, is done by the Looker data model. And what this accomplishes is a couple things. One is that you're not having to go back to the owner of the database if you are not that person to have them transform and clean the data. And the second is that we have transparency about how that data is being transformed or cleaned. So typically when you have a typical workflow, an engineer or a database administrator might be going in and manually computing or changing the data as it comes in, and that process is not transparent to the rest of the company, particularly non-technical users or folks who want to pull that data. So instead in Looker, you're doing all of the transformations. There might be some heavy-duty transformations you prefer to do at the database level. That would be the only exception if they're very expensive computations or things where you need more of a derived table or a persisted table that is containing summary data. Other than that, all the transformations are happening on the fly, and they are completely transparent in terms of what is being done to that data. And I hope that answers the question. If not, folks, please feel free to keep adding questions. I don't know how much time we have, Bill, but I can answer a couple others if there is any time.
Okay, well, Haarthi, Olivia, Julian, hey, thank you for some great answers to some very good questions. And for those of you who asked questions that weren't answered today, we'll be sending all the unanswered questions to Haarthi, Olivia, and Julian and the Looker team so they can follow up with you following today's webinar. You know, I have just a few quick announcements. If you'd please mark your calendars for June 12th, that's our next DSC webinar, which will be Life as a Data Scientist and How to Become One. And that's going to be sponsored by Springboard. Also, today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Looker for their sponsorship, as well as to our speakers today, Haarthi Sadasivam, Olivia Winter, and Julian Winternheimer, for their insight into today's topic. This is Bill Vorhies. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on June 12th. Have a great day.